Okay, good day. This is Math 140 College Algebra. I'm Professor McCulley. This is lesson 6-3 on exponential functions. Let's get right to it. Today we are going to recognize and evaluate exponential functions. We're going to graph exponential functions, and we are going to recognize and evaluate exponential functions of base E. So first off, what is an exponential function? So any function that is in the form f of x equals ab to the x is what we would call a general exponential function. And these come in different forms that have specific use. The simple interest function, a equals p times 1 plus r to the t. The compound interest function, a equals p times the quantity 1 plus r over n to the nt. And a equals PE to the RT for continuous growth. You'll notice here's my f of x, here's my a, this quantity here is my b, here's my x. Same thing with these. There's my f of x, there's my a, this quantity here is the b, and this is the x. There's your f of x, there's your a, E is the B, and this RT is the X in that. In each of these instances, P represents the principal or the initial amount. R is the rate written as a decimal, so you have to change all of your percentages into decimals. So 10% would become 0.1, 5% would be 0.05. N is the number of compounds, so if something said was compounded monthly, you change that to 12. If it was compounded daily, you change it to 365, and T is the time unit, usually in years, but that's not always the case. A general exponential function, when x is positive, the graph shows exponential growth, and when x is negative, the graph shows exponential decay. That is all provided that both a and b are greater than 1. So what does something like that look like? An exponential growth function is going to look like this, where you have this function here, and this value here is a. And that makes sense because we remember that anything to the 0 power, when x is 0, will have b to the 0. So anything to the 0 power is 1. 1 times a is always going to be a. And when we have y equals ab to the negative x, you can kind of think of that as a reflection about the y-axis. So we're still going to have that a right about here, but our graph is going to look something like this. All right. Just a quick review of some exponential property reviews. If you have a to the x, okay, I said that backwards, x to the a times x to the b, you add those two. So if I had a squared times, let's do it right there, Macaulay, a squared times a to the third, we would say that that thing is going to be a to the fifth because we're going to add 2 plus 3. If we have x to the a over x to the b, we're going to subtract. So if we have a to the third over a squared, that thing will just be a to the first. X to the a to the b, you multiply your exponents. So if we had x squared to the third, that result would be x to the sixth because we're multiplying. If we had, let's say 2 over x all to the fourth power, this thing would be 16 over x to the fourth, and it's 16 because 2 times 2 is 4, times 2 is 8, times 2 is 16. And then this is the one that a lot of people tend to miss. If I had 3x quantity squared, excuse me, then I would go 3 squared x squared, which would be 9x squared as my final answer for that one. And recall rational exponents. So if you had, let's see here, the third root of x to the fourth would be x to the 4 over 3. So just some simple review of exponential properties. Asymptotes. There are asymptotes with exponential functions. Exponential functions have a single asymptote. Generally, an asymptote The exponential function has a horizontal asymptote, and that is y equals 0 as soon as x goes to negative infinity. And we see that right here for the general exponential function. If it is a exponential decay, then it will be as x goes to positive infinity. But without any other transformations, you're generally going to have the x-axis be your horizontal asymptote. There is no vertical asymptote in the general form, even though it's going to go up far steeper and steeper and steeper. E is the natural number. It is part of the continuous growth function, which I call the PERT equation. A equals PE to the RT. PERT is PERT. And E is the natural number, and you can find it on your graphing calculator. If you look for this, let me clear this stuff out here. If you look at your LN button, the second function is e to the x, and so if I go second and I go e to the x and I hit a 1 there, we can see that e is 2.71828. You should think of e is to exponential functions the same way that pi is to circles. And I'm never going to have you memorize it because you would never use e without calculator, just because the results are going to be difficult to calculate. So some examples: describe the transformations from F to G. Use the transformations to label the domain and range. So this thing right now, as it is written, has a domain of all real numbers, and its range is going to be y greater than 0. And that goes back to this original function here. And so if I look at this, I got a lot of transformations here. And remember, I see this +2, this -2 here, and this -3 here. So I see 3 transformations here. Actually, we could technically call it 4, but yeah, let's call it 4. All right, so how do we read those? Remember, you read your transformations by plugging in and seeing what happens. So let's say I said x was 5. When I plug in 5, the first thing that's going to happen to it is I'm going to add 2 to that 5. That is going to be a translation. 2 units left. And it's left because you do the opposite when you're adding to the variable. Then I do the exponent. After I've added 5, I'll go 4 to the 7. That is the function. Then I multiply by -2. So these two can be different. Can be done at the same time. We could say that it is a horizontal stretch by a factor of 2, and it will be a reflection in the x-axis, excuse me. And we're multiplying the function by, so we're multiplying the y values by -1, so that's going to reflect the y values, meaning positive y values become negative y values, so it's a reflection in the x-axis. And then we'll subtract 3, which is a translate 3 units down. So this original graph looks something like this, and my new graph is going to look something, let's see, something like this. So my domain will still be all real numbers. The stretch really doesn't have a whole lot of effect on it. Reflection in the x-axis does, and so I reflect that over and then move it down. So this horizontal asymptote is gonna be at -3, and so my range is going to be y is less than -3. And if you need to, you can check that on your graphing calculator. Evaluate the function at the given value where x equals 2.2. So we're trying to figure out 2e to the 2.2. So we'll go to our graphing calculator here, and we'll go 2 times. We'll go second, we'll go e to the x, and we'll go 2.2 to put that in. And that value is 18.500. So 18.050, 3 decimal places. All right. And then the next one here says use graphing utility to find any points of intersection of the two given functions. So I have two different functions. We want to use a graphing utility to do that. So we are going to go to our y equals. We're going to clear out stuff from the one before it. The first function is 15e to the 2.4x. So 15, and then second e 0.24x. And then the next one was 45. All right, so before we get started, before we hit graph, let's think about what this thing looks like. Actually, you know what? Let's just hit graph. We see that. Okay. So we have two graphs here. This first one, we know has to look like this because it's an exponential. Because that leading value there is that a value, that first value there, we know that that has to be 15. This thing is a horizontal line at y equals 45. So if this is 15, 45 is way up here. So we know that we're going to have an intersection point somewhere way over there up high. All right. So I look at my graph, hit my graph here, look at my graph. I think it's very likely I don't have to change my y's or my x's, but definitely have to change my y's. I'm going to change my y maximum. I'm going to put that up to 60 just so I can see it. And we'll go by 5s and we'll hit graph here. And look at that. Lo and behold, there is our graph. So we want to find the point of intersection. And so we're going to go second. We're going to hit that trace button. We're going to hit the 5 for the intersect button. We're going to hit our right arrow key on the D-pad until we get close. That's close enough. I'll hit enter the 3 magic times. And my intersection point is 4.578. Comma 45 because it has to. That is what the y equals. And we see that's true right there. Box that up. Point of intersection. And that's it. And that's all I got for today, folks. So today's Marvel fun fact of the day: Spider-Man Into the Spider-Verse 2018 is Stan Lee's last voiceover appearance in a Marvel property. He passed just 1 month before the release of the movie, and watching that one always tears me up. I know you guys will think I'm a soft old man, but that one does make me misty. Have a good day, folks. Goodbye.